In our previous lesson, we used the NP where function to perform some interesting operations. And where is typically used to clean data from a data set. So perhaps you have some random data that can't be used, you need to standardize it, or you need to change your data based on some condition. We can run the where function for that. Let's demonstrate this with the 4x4 random array. And we have negative and positive numbers here. With the mean of 0. We can check to see which numbers in this are greater than 0 and set those to true, and the negative numbers will all be set to false. So this should create a corresponding Boolean array. So here's a positive number that's true. Here's two negative numbers which are both false. And that's our condition that we're going to use here in this where method. So as before, we put the condition first, and then we put the primary operation second, and the secondary operation third. So we're saying here that where the condition is positive, we want to change that to a positive 2, but where it results in a false, we want to change that to a negative 2. And you'll see how this standardizes our data. And oftentimes it's very useful for perhaps certain questions that we're asking, where we want faster computation or we want normalized data, we want either a yes or no answer, that we can do this type of operation. What if we want to replace only our positives but leave our negatives as is? Well, let's create another array, this time a 4x5, and we have the same parameters in position 1 and position 2. We're saying if it's greater than 0, replace it with a 2, but for everything else, just leave these values in place. And you indicate that by just passing the data set back in as the second parameter. So if we run this, we'll see that it has only changed the positive numbers. It's left the negative numbers as they initially were here. We also have mathematical and statistical methods at our disposal. These are called aggregation operations. We're trying to get some simplified insights on this larger set of data. So let's run this. We can get the mean or the average of these values quite easily. So it looks like the average amongst these is 0.25. It leans a bit towards the positive side, doesn't it? So we also have standard deviation here. It looks at how spread out a group of numbers is from the mean. If we run this, we'll see that it's about 1.23 from 0 in the negative direction and about 1.23 from 0 in the positive direction. We also have this summation function where it'll simply just take all of these numbers and add them together. This next portion, aggregation by axis, is going to require us to remember that this is the 0 axis and this is the 1-indexed axis. And so when we're asking to do a summation across the first axis, this is going to be the horizontal axis in this case, in the case of a two-dimensional array, and this will be the vertical axis. Let's run this and I'll show you what I mean. This 4 represents our first dimension, whereas this 4 represents our second dimension. So this is the 1-indexed axis, and this is the 0-indexed axis. Let's clear this and see what the sum function does. What we're doing is summing across the horizontal axis. And we see that the sum of these numbers is 6. But the sum of these numbers appears to be 22. The sum of these numbers appears to be 38. And our third indexed horizontal axis is 54. Now we can do the same operation manually and we get 6 as expected. This is the same operation happening. We can also sum vertically down the rows by requesting the 0 axis. So let's run that and we'll see that 4 plus 8 plus 12 is 24. And once again we can run the same function manually. The last topic for this video is these accumulation functions. So we have created this accumulation array, looks like a 3x3. We're going to cumulatively sum along the y-axis this should be the columns. Let me change this and run this. And so we're saying, okay, what's a 0 plus 3? Well, that's going to be 3. But 0 plus 3 but plus 6 is going to be 9. But 10 plus 4 is 14. And then 14 plus 7 is 21. So you can see the difference between a cumulative sum and a value by value summation. Here we have another method called cumulative product. Well, let's run it. We see that 0 times 3 is 0, and 0 times 6 is also 0. So it's multiplying down the columns. And here we see that 10 times 4 is 40, and that 40 times 7 appears to be 280. There are other statistical methods available in NumPy, and you can find a full list of them here in this documentation.